All right, guys. So here's what we're doing. We're finding the zeros of a polynomial function. In other words, solve for x when the function has a value of 0. So if you replace the function with 0, well, that's just if you look at that in a graphical way, that just means find the x-intercepts. So depending on the context, you might say find the zeros of the function or find the x-intercepts. It's the same thing. Now, this one's factored for us, which really makes it easier. So we can just say, all right, well, I'll just set each factor equal to 0. And it's been a long summer. Let's see if I still remember how to do this. Okay. And then we solve each one. Well, this first one, clearly it doesn't work. So there's no solution there. All right, no problem. The second one right there, take the square root of both sides. And we get -6. All right, so we've got 1 0 of the function. Cool. Add 4, subtract 9. Take the square root. And yeah, we can get plus or minus 3i, but we're looking for real number zeros, not imaginary. So that's not going to cut it. So we've only got 2 of them this time. All right, -6 and 4. So what I'd like to do is kind of compare that with the x-intercepts of the function. Okay, and so what I'm going to do is I'm going to plug this function into the calculator. Okay, so I've got the function in the calculator, and so let's just zoom 6 is probably going to get it done. It's not show. Whoa, that gets really steep right here. So steep that the calculator cannot distinguish it from a vertical line, so it's not drawing it. Poop. Okay, well, for one thing, okay, so we're finding the zeros of the function, or the x-intercept, so I can certainly see one there. So let's go second trace. Now, 0 means zeros of the function. And it says, we're going to do the left bound, right bound thing. So I'll use my side arrows. And it looks like it's at 4 exactly. I'm watching my x coordinates of where I'm at because they're not showing up on the screen. And because it's so steep there, it's probably not going to show up. Okay. Well, okay, that's to the left of x equals 4. So I'll hit enter. Then it says go to the right. All right, that'll be to the right. Okay, and those 2 dotted lines, yep, they contain the function right there. Enter, and yep, the 0 is at x equals 4. I wonder if the other one is over here at x equals -6. It could be. You know what? It's not showing it, so maybe I'm going to try zoom 0. Let's stretch this thing out. Maybe that'll do it. That really popped it out vertically. Let's see how far. Okay, so on the bottom, -97,000 on the top, just about getting on 700,000. So yeah, that's why it was so steep, because, well, okay, so let's go second trace, option 2. And we're trying to find this other 0 over here. Okay. And let's see, does it ever, wait a minute. No. Does it ever go up above the x-axis? Doesn't look like it. Well, we'll go to the left of it and hit enter. Go to the right of where it looks like it's first hitting the x-axis and enter. And I'll give my best guess. Enter. And and it's got a problem there. Okay. Well, so apparently it didn't work that way. But remember, we know that we're just looking for when y equals 0. And we claim it equals 0 when x is -6. So let's go to the table and say when x is -6, look at that, y is 0. And when x is 4, y is 0. So that confirms those are the zeros of the function. That -6 and 4 cause the function to be equal to 0. All right, so now we're going to find the x and y-intercepts. Well, we just did x-intercepts a moment ago. To get x-intercepts, you set the function equal to 0 and solve for x. So let's do x-intercepts right now. Okay, so, but we've got 4 terms here, and I'm not sure how to handle that. I can't run it through the quadratic formula. I don't know how to factor it, but, oh, wait a minute. I remember we learned a technique called factoring by grouping. Okay, in fact, it's so cool. I'm going to write it down right here. When you see 4 terms, factoring by grouping is probably going to be the way to go. And what you do is you group up the first 2, group up the last 2, and hopefully you group them up correctly. If not, you move the terms around and try again. And then you factor what you can. Factor out the GCFs, the two binomials. So out of these 2, I can pull out an x squared. And out of the second binomial, I can pull out a -4. And if everything is going according to plan, these 2 guys are going to be the same. If they are not, then you got to try something else. But they are the same. And so I can now factor an x plus 5 out of both of them, which leaves me with x squared minus 4. Aha! Now it's factored. So now I can set each factor equal to 0. And get x plus 5 equals 0, so -5. And x squared minus 4 is 0. And so positive and -2. So there are 3 x-intercepts. That's what I expected, because the highest power of the variable was 3. It doesn't guarantee there'll be 3, but it's a good bet. So that's how you get the x-intercepts. Just set y equal to 0 because x-intercepts occur on the x-axis where y is 0. Okay. Now, what about and of course you can confirm that on the graph or the table of your calculator, and you should. Now, to get the y-intercepts are on the y-axis where x is 0. Okay, so let's replace x with 0, which usually is a lot faster and easier, and so it is here. Notice that goes to 0, so does that, and we're just left with -20. Bam. And that'll be our y-intercept. And again, you can and should confirm that on your calculator. Be able to do it by hand and by calculator. Okay, you know what? I should probably make that, let's make that bigger. Yeah, that's big enough. Okay, so we won't be able to see the last problem, but that's okay. We'll still do 2 of them. Okay, so on this one, find the end behavior. All right, now normally when we graph functions, what we're interested in is, maybe the x-intercepts. Okay, like we just were a moment ago. Or maybe we're interested in the y-intercepts. Or maybe we're interested in the relative maximums or the relative minimums, or whatever. If you go into calculus, you'll worry about inflection points too. All right. In this case, what we want to do is worry about the end behavior. Okay. What's the end behavior? So after all the interesting stuff happens in there, which direction does it go? Okay. So there's only 4 choices of what it might be. Okay. And they list them right there. You can have falls to the left and rises to the right. Or this one, you can have rises to the left and falls to the right. Third one is rises to the left, rises to the right, like a parabola. And the last one falls to the left, falls to the right. like a parabola opening down. So that's kind of what they mean. The middle stuff going on, we're not even paying attention to that. When you see end behavior, you don't even worry about the middle. Okay, you're just worrying about what's going on at the ends. So it's a little different than what we normally do. Now, you can, I'll be honest, you can always just graph it on your calculator, zoom out to, far enough so you can see what that end behavior is, and then just pick the correct one. And I can live with that. Okay. If you know how to do it, if you learn the pattern, it goes faster. It goes much faster. For example, I look at this one and I say to myself, it's that right there. Okay. The next one is going to be that one right there. I can tell just by looking at it that fast. Then again, I have practiced this. So how am I doing it? Well, there's two main things. Okay. There was the end behavior where, the two ends are doing opposites. One's going up, one's going down. Okay. So, all right, these occur when the leading coefficient or leading exponent is odd. If the leading exponent is odd, then it's going to be one of these two. It won't be the parabola. Okay, so that tells me it's not the parabola right here. Okay, so which of these two is it going to be? Well, the leading coefficient is negative, which means it's going to be going downhill like that, ultimately, like this guy here. So it's going to fall to the right and rise to the left. Bam, just like that. So the first thing you do is you say, all right, the leading exponent, is it even or odd? If it's odd, then it's not going to be the parabola. It's going to be one of the other two. Then that leading term, if it's negative, it's going down. And if it's positive, it's going up. All right, so on part A, the leading exponent is even. So we know it's going to be parabolic, like that or like that. So it's not going to be either of those. And the leading term is positive, so it's going to be going up. So it's going to be doing rises in both directions. Done. And that's all you got to do. As you get good at it, it goes very fast by hand, definitely faster than by calculator. Although, please feel free to check it. Okay, I apologize. On this one, I do have to zoom out a bit. Hope you're not watching this on your phone. But I got to zoom out so I can show all the way down to here. Okay, so consider the polynomial function, and immediately we're thinking things like, hey, they give me the function. Great. And hey, it's all factored. Oh, that definitely makes it easier. All right, choose the end behavior. All right, so we've got 1x, 2 more x's, 2 more x's. So that's going to be, if you multiply this all out, you're going to have highest power is going to be 5. Okay, highest power of x is going to be 5. So we know it's going to be like that or like that for the end behavior. All right, now it's going to be a positive 1x times 1x squared times 1x squared. That's all going to end up being 1x to the 5th, as in positive 1. So we know it's going to be going up. Okay, going up. So the end behavior is going to be falling to the left and rising to the right. Okay, or an increasing function, whatever. Okay, so that's going to be the answer to part A. Part B. And what we're doing here, this is kind of the old-fashioned way of doing it. Before we had graphing calculators, it was like, okay, let's examine different parts of the function so we can get a reasonably good graph. So that's kind of what's the idea here. I know you're thinking, I got a graphing calculator. I know. Okay, part B. List each real zero. Okay, the zeros of the function. So replace the function f of x with 0. Find the x-intercepts. The graph at the x-axis near that 0. Okay, if there's more than one answer, separate them. Okay, so go find the zeros. All right, so we'll replace f of x with 0. And since it's all factored, I can set each factor equal to 0. And square root, add 2. Square root, subtract 1. Okay, and we have 3 x-intercepts. Okay, 1, -1, and 2. All righty. Zeros, where the graph crosses the x-axis, and zeros where the graph just touches it, but doesn't cross it. All right. And you can double check this all on your graph, but it crosses the x-axis when x is 1 and -1. No, I'm sorry, just 1. Okay, and it just touches the x-axis when x is 2 and -1. How do I know that? Because this factor of x minus 1 that gives us the x-intercept, or the 0 of 1, that factor occurs only once. It's just x minus 1 in the function. But x minus 2 occurs twice, and x plus 1 occurs twice. And so when they occur twice, then they're just going to come up and just kiss the x-axis and then drop back down. I mean, just barely kiss it, like you're kissing your sister on the cheek. Okay, or come down and drop back up, or go back up. But they're not going to cross at that point. And of course, you should be double checking this stuff. All right, so we got all that. Let me just get rid of all this stuff here. Okay, part C, find the y-intercept. All right, y-intercept's easy. Replace x with 0. Okay, and we get -1 times -2 squared times 1 squared. Let's see, that'll be -4. So y-intercept is going to be -4. You check that on your calculator. Okay. All right, part D. Graph the function by doing the following. You plot all the information that you used. Okay. Or that you found. Okay, so we found, let's see, 1, 2, 3, 4. So we found a y-intercept there. We found an x-intercept there. We found another x-intercept there. One there. Okay, and we know it starts low and it goes up. So we got to start down here. So, I would want to double check this. I'll let you double check it on your calculator, but I figure it's going to go up like this. Now we said that when x is -1, that it doesn't cross. So it's just going to go up and come back down, hit this guy. Okay, that makes sense. And we said that when x is +1, it does cross. Right. And then the last x-intercept, it does not cross, and it goes up like that. And that should be approximately what it looks like. Not perfect, but better than I would typically draw freehand. Okay, kind of the same idea. Below is the graph of a polynomial function with real coefficients. All local extrema of the function are shown in the graph. Okay, local extrema, those are the local maximums and the local minimums. That's all they mean by that. It's just a local extrema means the local extreme values. Extreme value, those points that are the highest or lowest in their own little neighborhoods. Okay. So, over which interval is the function increasing? Well, we read graphs from left to right. So from left to right, where is it increasing? From left to right, it's increasing right here, and right there, and right there. That's where it's increasing. It's decreasing on the other ones. Okay, so so when x is -infinity to -8, that's that region right there. So, yep. How about -8 to -6? That's going to be right there. So no. -6 to -4 would be that region. So yep, or doodle. -4 to -2. Nope, that's decreasing. -6 to -2. That would be from -6 to -2. Well, it is increasing, but then it's decreasing again. So we're going to say no. And -2 to infinity would be this guy. It's very Buzz Lightyear. So yes, that works. Okay, so those are the intervals. Now, at which x values does the function have local minima? Well, the local minimums, those troughs, are right there, and the x values are -6 and -2 for the local minimum. If they ask for the local maximums, the x values, then that would be -8 and -4. And that's the way we do it now. I like it.